Good morning, students. Today I will explain you electromotive force. So it's a very important thing. First point is that what is electromotive force of the cell? To understand electromotive force, first you go through the cell. You see, in a cell, two electrodes of the different metal and an electrolyte. This completely forms a cell. Now, here we take zinc and the copper as the two electrode, and we take electrolyte as sulfuric acid in water or the direct sulfuric acid. Now in water, this sulfuric acid breaks into sulfate ions and the hydrogen ions. These sulfate ions moves toward the zinc and gives its electron, and the hydrogen ion moves toward the copper and takes these electrons. Now here zinc becomes cathode, that is a negative charge, and the copper becomes the positive charge, that is anode. So we say in the cells a difference in the concentration of the electrons is maintained on the electrodes. The point is that a chemical reaction is going on in the cell, and due to this chemical reaction in the cell, a difference of the concentration of the electron is maintained on the electrodes. So we say that this chemical energy is converted into the electrical energy and is stored in a cell. Again listen, these chemical reactions, that is the chemical energy, is converted into electrical energy and is stored in the cell. So when no current is drawn from the cell, or we say when it is open in the circuit, the potential difference between the terminals is called the electromotive force. So that is stored energy in the cell, where during the chemical reaction this chemical energy is converted into electrical energy. So electromotive force, that is the potential difference between the two terminals when there is no current drawn from the cell. Now this electromotive force unit is V, and it is denoted by a letter that is known as the epsilon. Now see again, if this circuit is closed, by taking an appliance in the circuit, then what will happen? Suppose here we put a conductor in the cell and we complete the circuit. Now this is a very important thing. He will say that the current moves from a terminal, goes to the appliance, then come back. Now here is a complete circuit, that is open circuit and the inside circuit. So from A goes to the appliance, then return back to the cell. So complete circuit is the circuit, that is the outside circuit and the inside circuit. So we will say that the total work done in carrying a unit charge particle is the outer circuit and the inside circuit. So when circuit is closed, then EMF is defined as the energy spent or the work done per unit charge in taking a positive test charge in the complete circuit, that is outside and the inside circle. So again listen, when a appliance or a conductor is taking in the circuit of the cell, then the total circuit of the cell is outside circle and inside circle. Outside circle means appliance and the inside circle means when the electron flows inside the circle, inside the cell. So we will say that when circuit is closed, the EMF is defined as the energy spent or work done per unit charge in taking a positive test charge in the complete circuit, that is outside and the inside circuit. So this EMF, if capital W is the total work done in Q charge. Now things at this point, this EMF, that is work done, this work done is total work done in carrying charge particle outside circuit and the inside circuit. It's very important thing. Now in the case of the outside circle, the difference between the two terminals, when we take the outside circle only, that is known as the terminal voltage of a cell. Terminal voltage of a cell is defined as work done per unit charge in carrying positive charge around the circuit between the two terminals, that is only outside circuit. Here this V, that is the terminal voltage, is equal to the amount of the work done. Same thing. Here the work done, if we represent by W1 charge Q, then the terminal voltage is equal to the work done W1. Now what happens inside the circuit? That is inside circuit, inside the cell. It is known as the voltage drop. That is work done in carrying unit positive charge in internal circuit, that is from B to A. So here this voltage drop we represent by small v, it will be equal to the amount of the work done. Here we will write the small w and the Q charge. Now I said that the total work done in outside and inside circuit, that is capital W is equal to W1 plus small w, that is work done in the terminal voltage, that is outside circle, and a small w, that is voltage drop inside circle. So total work done, capital W is equal to W1 plus small w. So W upon Q is equal to W1 upon Q plus small w upon Q. Or we say that the EMF is equal to terminal voltage plus voltage drop. Here if you find the terminal voltage, that is V, is equal to EMF minus small v, that is the voltage drop. So here point is that the terminal voltage is always less than the EMF. Now suppose we draw more current, then there will be more work done inside the cell. So we will say that terminal voltage is always less than the EMF. So it's a very important thing. So EMF simply, that is the potential difference between the two electrodes of the cell when it is not used. But when it is used, that is, it is taken into the circuit, then it is equal to the work done. That is defined as the energy spent or work done per unit charge in taking a positive test charge in the complete circuit, that is outside and inside. And in both the circuits, in open this outside circuit, terminal voltage there, and in the inside circuit, that is voltage drop. So we will say that the total work done is the work done in the outside circuit and the inside circuit. So EMF is equal to terminal voltage plus voltage drop. Then terminal voltage is equal to EMF minus voltage drop. So we say that the terminal voltage is always less than the EMF. So I think it is clear to you. If you like my videos, please share and subscribe. Thanks very much.